तो हम लोगों ने मेट्रिसेस की बात की थी, राइट. वी टॉक्ड अबाउट मेट्रिसेस, वी टॉक्ड अबाउट मैट्रिक्स एडिशन, मैट्रिक्स सब्ट्रैक्शन, मैट्रिक्स मल्टीप्लिकेशन एंड इनवर्स ऑफ अ मैट्रिक्स, राइट. नाउ वी विल बी स्टार्टिंग विद डिटर्मिनेंट्स. सो लाइक सपोज हम लोग को दी होती हैं एक आपकी इक्वेशन. तो हम लोगों ने पढ़ा था एलिमिनेशन मेथड और सब्स्टिट्यूशन मेथड, याद है, राइट. सो वी हैड इक्वेशंस इन एक्स एंड वाई. सपोज टू वेरिएबल की जो हमारे पास इक्वेशंस होती हैं, इक्वेशंस इन टू वेरिएबल्स, इक्वेशंस इन थ्री वेरिएबल्स, राइट. सो सपोज इफ वी आर टॉकिंग अबाउट इक्वेशंस इन वन वेरिएबल, टू वेरिएबल्स, तो हमारे पास लीनियर इक्वेशंस. सो जब हम बात कर रहे थे लीनियर इक्वेशंस की, हम पढ़ते हैं लीनियर इक्वेशंस में एलिमिनेशन मेथड एंड सब्स्टिट्यूशन मेथड हम लोगों ने वहाँ पढ़ा हुआ है. एंड हमने ये भी पढ़ा है कि कौन सी लाइंस पैरेलल लगती हैं, कौन सी लाइंस कोइंसिडेंट होती हैं और कौन सी लाइंस क्या कहते हैं, दे हैव अ यूनिक सोल्यूशन. वो सब हम लोग पढ़ते हैं. नाउ दीज कैन ऑल्सो बी सॉल्व्ड विद द हेल्प ऑफ मैट्रिसेस. How should we go about it is, if I take A as A1, B1, A2, B2, and then I take say X to be X and Y, right, and then I have a matrix say C which is C1 and C2. So can I write these set of equations as A X is equals to C? मैट्रिक्स मल्टीप्लिकेशन देखा है हम लोगों ने, कैसे होता है मैट्रिक्स मल्टीप्लिकेशन. सो इफ आई एम सेइंग A into X, what it would look like, A1 X plus B1 Y, that would be, ये कितनी है, ये 2 cross 2 मैट्रिक्स है. What is this? This is 2 cross 1 मैट्रिक्स. तो AX would be a 2 cross 1 मैट्रिक्स. C is a 2 cross 1 मैट्रिक्स. So we can talk about equality. दो मैट्रिसेस कब इक्वल होती है? When are two matrices equal?
When their order is same.
When their order is same, and then when each corresponding element is equals to the corresponding element. So हम उसकी बात करते हैं. तो सबसे पहले हमारे पास क्या आता है? So AX would look like what? AX would look like A1 X plus B1 Y, right? And then the second, what would be the second element look like? A2 X plus
B2 Y.
And we can write this as C1 and C2.
Yes.
So if they are equal, that means what? A1x plus B1y is equals to C1 and A2x plus B2y is equals to C2. This is the set of equations we were talking about. Now how do we solve them? We know how to take out inverse. So suppose I know A inverse. Suppose I know A inverse. So can I not say that x is equals to A inverse C? Can I or can I not? How do I arrive at this? I know that AX is equals to C. I am pre-multiply it with A inverse. So A inverse AX is equals to A inverse C. Right? And then matrices with respect to multiplication are associative. So I can say that this can be written as A inverse AX is equals to A inverse C. And what is A inverse A? Identity. And then identity matrix into X would be what? X itself.
X itself.
So what would I get? X is equals to
A inverse into inverse.
So if I can take out A inverse, I can solve these. Now talking about elimination and substitution method, it is really easy to do it with elimination and substitution also. But what if I have like n variables? And I have an n cross n sort of, like I have n, I have n equalities here. Suppose I have x1, x2, x3, x4, x5 up till xn variables. और हमारी n वेरिएबल्स में कितने हमें इक्वेशंस चाहिए होंगे टू गेट द आंसर? n इक्वेशंस. If you have linear equations in two variables, you require two equations to solve them. अगर मैं ये हटा दूँ तो can you solve the equation? You will not get a unique solution. So I need at least n equations to solve a linear equation problem for n variables. n variable की problem के लिए मुझे n equations चाहिए. So when I'm talking about a number of equations, so solving them by elimination and substitution becomes a difficult task. So what I can do is I can go about like this, right? So what would we do about it is the question now. So now we are talking about determinants. All right, so before talking about determinants, okay, so now what they are trying to say here is that this system of linear equations has a unique solution. When हमारे पास जब इक्वेशन दी जाती थी दो, तो हमने पढ़ा था ना that it has a unique solution, it has n number of solutions, or it has no solution at all. When was that happening? When we used to say that it has a unique solution?
ax1 equals to b1y is not equals to
a1 upon a2 is not equals to b1 upon
b2.
Then we used to have a unique solution. When a1 upon a2 was equals to b1 upon b2 but not equals to c1 upon c2, no solution. And when all three were equal, we used to say that they are coinciding lines. Yes, that means there were many solutions possible. तो हम क्या कहते थे कि इनकी कब when is it possible that these two have a unique solution? When a1 upon a2 is not equals to b1 upon b2, and we can also write it as, what can we write it as? That a1 b2 minus a2 b1 is not equals to 0. ये भी तो कह सकती हूँ मैं, right? If I am saying that a1 upon, for a unique solution of these equations, I want a1 upon a2 should not be equals to b1 upon b2. So what does that mean? That means that a1 into b2 should not be equals to b1 into a2. So if I bring the right hand side to the left hand side, what I can say? a1 into b2 minus a2 into b1 should not be equals to 0, right? So this is exactly what we call the determinant of a 2 cross 2 matrix. एक 2 cross 2 matrix का determinant कितना आता है? a1 b2 minus b1 a2. That is the determinant of a 2 cross 2 matrix that we'll be starting with. But my point is कि ये कह रहे हैं that by looking at the matrix only, you should be able to tell if these will have a unique solution or not, and how if the determinant is not equals to 0. So if we go back to remembering कि हम जब याद करते हैं, मैंने कहा था इनवर्स, तो मैंने कहा था कि हर मैट्रिक्स का इनवर्स एग्जिस्ट नहीं करता. एंड देन आई टोल्ड यू कि जब हम डिटर्मिनेंट्स पढ़ेंगे तो विल कम अक्रॉस कि जिन मैट्रिसेस का डिटर्मिनेंट 0 नहीं होता उनका ही इनवर्स एग्जिस्ट करता है. कुछ याद आ रहा है? When I was talking about inverses, I told you people that when we will study determinants, we'll come across the term ki, I told you that not all matrices are invertible, right? And वहाँ पे हम लोगों ने क्या पढ़ा था that by after doing row elementary operations or column elementary operations, at a certain point while solving, if you come across that an entire row has become 0 or an entire column has become 0, that means that the inverse will not exist, right? तब मैंने कहा था कि इतना भी सॉल्व करने की जरूरत नहीं होती. When we'll study determinants, we'll realize that the matrices whose determinant is not 0, only they have inverses. The matrices whose determinant is 0, they do not have inverses. They are not invertible. So coming back to that point, जब मैंने कहा कि इनको हम कैसे सॉल्व करेंगे, so for solving them, what do we require?
Inverse.
A inverse, right? So if there exists A inverse, then only we'll be able to solve it. If A inverse does not exist, would we be able to solve it? And that is exactly the concept coming back to it is कि अगर determinant 0 नहीं होगा, if the determinant is not 0, that means what? The determinant is not 0, that means A is invertible. A is invertible, that means the unique solution would exist. So do you see कि हम जो भी पढ़ते हैं it is somehow or the other connected. Can you see the connection here? कि this is the determinant जो हमने इनिशियली पढ़ा था कि इनका सोल्यूशन कब एग्जिस्ट करता है when a1 upon a2 is not equals to b1 upon b2. That implies that the determinant of this matrix should not be equals to 0, and if determinant is not equals to 0, that will imply that A is invertible, and that will automatically give leads to the point that there exists a unique solution. So determinants से हम लोग आगे बढ़ते आते हैं एंड वी आर टॉकिंग अबाउट कि ओनली स्क्वायर मैट्रिसेस हैव डिटर्मिनेंट्स. तो सिर्फ स्क्वायर मैट्रिसेस के डिटर्मिनेंट होते हैं. सेकंड, व्हेन वी आर टॉकिंग इन टर्म्स ऑफ मैट्रिसेस, दिस इज नॉट मॉडल, दिस इज डिटर्मिनेंट ऑफ. So how is determinant of A written as? Denoted by determinant of A is denoted by this, or what is this? This is pronounced as determinant of A. Now let's talk about what if is A is equals to a square matrix? Is A equals to a square matrix? It is. It is a 1 cross 1 square matrix. Okay. So when we are talking about, so the determinant will exist. The determinant, how is the determinant of a 1 cross 1 matrix defined to be? So determinant of A would be what? It could be exactly okay. So it would be what? Determinant of A, and that was defined to be A. Alright. So determinant of matrix A is exactly equals to A. When we are talking about a 2 cross 2 matrix, which is A11, A12, A21 and A22, how will we define the determinant of this matrix? So we will not write it like this. I am talking about determinant of this, that means this, right? So अगर मुझे इसको matrix की तरह लिखना होता तो मैं कैसे लिखती? Like this. But I am talking about determinant, so that means I am talking about determinant of this matrix. So how will this look like? So what do we do is we multiply A1 with A2 and A11 with A22 and A12 with A21, and what we do is we say A11 into A22 and then we subtract A21 into A12 from it. That is the determinant of this matrix. Okay. So what we'll do is we'll multiply A11 with A22 and then subtract the product of A21 with A12 from it. Alright. So for example, if I am supposed to take out the determinant of the matrix this is the very first example in the book. So if I am supposed to take out the determinant of this, what will it come out to be? 4, that is 2 into 2 minus 1 into 4, which is 4 plus 4, I guess. Alright. So now next, coming to the determinant of a matrix of 3 cross 3 order. How will we calculate that? Shall I write this? So when I am talking about a 3 cross 3 matrix, how would that look like? Suppose I am talking about determinant of A. So what we do is, let's remember certain things, okay? So how we go about in this determinant निकालने में plus minus plus, all right? And on column wise also we go what? Plus minus plus, okay? So what does this mean? First look here, then we'll write. So plus minus plus and then plus minus plus. So plus plus will give you a plus. So this is what? A plus element. Then plus minus will give you a minus. So this is minus, and then plus plus will give you a plus. So this is plus. So plus minus plus. Now next coming to here, plus and minus would give you a. So this is plus, this is minus, this is plus. This will give you what? Plus minus a minus. What will this give you? Minus minus.
Plus.
And what will this give you? A minus. Right? And then this plus plus a plus, plus minus a minus, and then plus plus a plus. Why are we doing this? No idea. Good. So moving on, when I'm talking about the determinant of it, so how would this look like? This is a plus, A11 is a plus. Alright. So either we calculate the determinant of such matrices by rows or by columns. So for calculating a determinant, first we need to decide a row. Any row it could be. Suppose we are calculating it by row. Okay? So we can take any row. Okay? Suppose I take the first row. That I am going to calculate it by the first row. So what I'll do is I'll take the very first element. What is its sign?
Plus.
Plus. So it will be plus A11. And then what I will do is I'll cancel the first row and the first column. Why? Because this is A11. So this is the element in the first row and first column. So I'll cross it out, and what I am left with? These. So I'll multiply it by the determinant of the next time. What? This is a 2 cross 2 matrix, right? So this is into the determinant of a 2 cross 2 matrix. And what is that 2 cross 2 matrix? A23, A22, A23, A32 and A33. Next, what I am supposed to do is I am calculating it by row. I have already taken the first element. Now what I am going to do is I am going to take the second element of the first row. What is that? A12. What is its sign?
Minus.
So I'll take is minus A12 into. And what is the matrix that I am left with? So what I'll do now is, this is the element of the first row and the second column. So I'll cross this out. And what elements I am left with?
A23 and A33.
I'm not supposed to cross this out, right? So now this time I'm only cancelling what? This one, right? So the first row that is supposed to be cancelled and the
Second
column. So now what I'm left with? I'm again left with the 2 cross 2 matrix. And what does that look like?
A21, A23,
A21, A23,
A31,
A31,
A33.
A33. Next, what I'm left with is the. Now I'm done with the second element, right? So now what I have is the third one. So I'll cancel the first row and the third column. And what is this sign? This is a plus sign. So I'll say plus A13 into, again I am left with a 2 cross 2 matrix. What is that? A21,
A22, A31, A32.
So that is how I'll calculate the determinant of a 3 cross 3 matrix.
Only the first row.
Only the first row. So when I'm talking about these plus signs and these minus signs, there is this formula that we talk about, but this is an easier way to remember it. What is actual formula? It is A11, right? This is the A1 position. So I have 1 to the power I plus j into Aij, and then the determinant that I have. So how we determine this will be a plus or this will be a minus? By minus 1 to the power I plus j. So this is what? Here I is also 1 and j is also 1. So what we will get? Minus 1 to the power 1 plus 1, which is 2. So this will be a plus 1.
Yes.
So this is a plus. Going here, 1 plus 3. Minus 1 to the power 3. So it's a minus 1. 1 plus 3, I have minus 1 to the power 4. So it is what? Plus. So either you can remember it this way, or you can remember it this way. Plus minus plus, plus minus plus. So are we clear how do we calculate this? Now what we are supposed to do actually is, so this is a determinant. Next what we are trying to say is, what if I am supposed to calculate in terms of a column, not a row? And do you realize कि मैंने पहली रो ली है? You could have also taken the second row, you could have also taken the third row, right? So if suppose I change it from the first row to the second row, right? So if I am changing it from the first row to the second row, what element do I have is A11, A12, A13, A21, A22, A23, A31, A32 and A33, right? So suppose I have taken the second row. So what elements would I take? I would take this and then cancel the second row and the first column. So I would have left with a 2 cross 2 matrix. What would that look like? A12, A13, A32 and A33. Right? So in this case, what you would start as? What is this? This is a minus. So you would have written minus A21 into, what would this matrix look like? A12, A13, A32 and A33. Right? So like that you would have gone about the second row also. उसके बाद हम कौन सा एलिमेंट लेते हैं? A22. You would cancelled this and we would have left with A11, A31, A13 and A33. Any doubt about it?
No.
We could have on the other hand also gone by columns. How about if we go about columns? So columns की तरीके से कैसे होता? So I can have A11, A12, A13, A21, A22, A23, A31, A32 and A33. So suppose which column should I take? Second column, okay? So suppose I am taking the second column. So what will be the first element of the second column?
A12.
A12. So this is a minus. So the first entry that we would have have been a minus A12 into, what would my 2 cross 2 matrix look like? I would have cancelled the first row and the second column, and I would have been left with
A21,
A21, A22, A23, A31 and A33. Next, what would I have done? I would have taken the
second one.
And what is this? This is a plus. So what would I have done is, I would have taken a plus A22. And what would I have been left with?
A11, A13, A31, A33.
A11, A13, A31 and A33. Last but not the least,
This one.
right? So this would be a minus A32 into what? This has gone and this has gone. A11,
A11, A13, A21, A23.
correct? So we could have also gone column wise. That is how you calculate a determinant of a 1 cross 1 matrix, a 2 cross 2 matrix and hence a 3 cross 3 matrix.